everyone, this is our final project presentation for DSBA 6156 with Cal Omicron and Smarun. Let's get started with a brief introduction of our project and what our essential problem and goal of this project was. The topic we chose for our final project was fake news detection in social media posts and news articles. We chose this topic because individuals are relying on the internet and social media to find information quickly. In fact, the internet has become a necessity for people globally. The necessity to know whether our information presented is increasing parallelly with the amount of data being generated is highly important, as individuals need to know where their information is coming from and whether it can be trusted or not. With that being said, our goal was to find an efficient machine learning model that accurately flags articles as reliable and unreliable when fed with an unseen dataset. During our exploratory data analysis phase, we performed the following pre-processing steps, including the removal of null values, removal of special characters because usually non-numeric and occasionally numeric characters add extra noise to unstructured data. We also removed stop words, which is very important, stemming, lemmatization, and as exemplified in the image on this slide, we performed various sentiment analysis techniques. We printed out the Vader polarity score, which identifies the text as positive, negative, or neutral, while considering the intensity behind it, like excellent. The word excellent would be considered more than the word good. We also looked at sentiment score, which determined if an overall text was positive or negative. Similarly with the sentiment vector, which identified positive, negative, and neutral emotions in text. Similarly, we implemented a visual of the polarity distribution for our dataset. We also implemented a sentiment per label box and whisker plot, where we could already see unreliable sources had negative average sentiment. And as far as topic modeling, we displayed a word cloud to see the most pertinent topics from news articles. We had our data at hand, but we were trying to look for research questions to ask rather than automatically answering what model would suit us best. These are the following questions that we were curious in answering. For example, one question we want to know is which authors or websites and articles stood out as unreliable. There were two websites that appeared frequently with a label of unreliable, which was the Daily Sheeple and the consortiumnews.com. And after more research on our part, we realized that both articles are considered left-centered bias, conspiracy-driven, and anti-science, and it was proven to not have very factual content. Similarly, we're wondering what certain words or sentiment changes occur with reliable data versus unreliable data. And given the box and whisker sentiment plot, during our exploratory data analysis stage, we noticed that a fabricated article may have more of a negative connotation considering it contains high bias or manipulated information. We're also wondering, for future purposes, how can someone avoid believing in fabricated articles? And that's when noticing, exaggeration, time constraints, or unrealistic offers in the text that you're reading. We filtered our questions to the important modeling phase. We researched models that would best help us in our classification predictions. We also considered some inputs from both the professor and TA, like increasing the data set. We implemented all of these models with an entire unseen testing data set that we increased to 50,000 records per request. We also applied hyperparameter tuning, which improved our results on logistic regression. And overall, the two-layer neural network, logistic regression with hyperparameter tuning, and a decision tree performed the best for us. We agreed to work evenly throughout the entirety of the project. Through frequent team meetings, we regularly expressed our individual findings of different modeling techniques and research points we can include to improve our accuracy. Overall, we learned a tremendous amount of concepts throughout the semester, throughout this project, and it validates the idea that machine learning can be and is applied to various real-world applications. This concludes our presentation, and we hope you enjoyed.